But what if I don't want to just compare one thing? Very quickly in Scratch, did you probably kind of construct scenarios where you want to check multiple things at once, or you want to ask multiple questions perhaps, or even if not, odds are you'll cross that bridge before long. So let me go ahead and do another example. This one I'll do from scratch. I'm going to call this noswitch.c for reasons that will become clear in a moment. And I'm going to go ahead and include the CS50 library. I'm going to go ahead and include the standard library so that I can get input and print output. Int main void, which is the one line we'll just take for granted today. And then here I'm going to do the following. Char c gets get char. And I just want this to be the user's answer. Char is a single character, not a string, which might be a whole phrase or paragraph. And then I'm going to do the following. If c equals quote unquote y, then I'm going to go ahead and print out yes. Else, if c equals quote unquote n, I'm going to go ahead and print out quote unquote no, semicolon, and that's it. So what's this program doing? Well, if you've ever run a program that has like a yes, no button to click, or maybe it is a command line program where you're using your keyboard and you have to type yes, I agree to the terms and conditions, or no, I do not. This is kind of like a super simple way of checking, did the human type y for yes or n for no? So let's run this and then come back to why it's implemented in the way it is. So make no switch. And again, I'll come back to why the name is what it is. Let me go ahead now and run / no switch, enter, and my answer shall be y for yes. It's buggy, right? What was I expecting? Yeah, I was kind of expecting if I hit y, then print yes. But let's think about what my code is asking. Wherein lies the bug? Why did my program not print yes? Yeah. Yeah, it's as simple as that. It's not capitalized. So here, too, precision, super important. I wrote a program that says if the char the user has typed in equals capital Y, print this. Else if it equals capital N, print that. I didn't do either of that. So the program's not broken per se. It's just not it's missing a feature, if you will. It's lacking support for lowercase. But if I do a uppercase Y, that, of course, works. So why is this written in the way it is? Well, there's a couple of details here. And this may be a question you would have based on your comment earlier. Why is it equals and not just equals like in math? This seems a little weird. Yeah. Yeah, it's the same kind of answer. Humans already used up the equal sign for a different purpose, for assignment, as it's called. Move a value from the right to the left. And so when they realized, oh, shoot, we kind of painted ourselves into a corner, how do we now check for equality, like in arithmetic? Well, you need a different symbol so the computer knows the difference. So equals means, unfortunately, equals. And equals means assignments. And that's all. And once you kind of remember that, it's all pretty straightforward, but that's why. There's another thing I did a little differently, and this is an annoying detail. Why did I suddenly switch, do you think, to single characters? Damn it. Why all of a sudden did I switch to single apostrophes instead of double quotes like I did before? Single quotes only work for characters. Why, yes, how astute. Yes, so that's exactly it. So single quotes, as I just wrote, are literally meant for when you have single characters, like y or n in this case. Double quotes are used when you have multiple characters for proper strings. And we'll tease apart why that is before long. But for now, that's literally the reason. If you're checking one character, it's literally single quotes. If it's more than one character, you absolutely need multiple quotes. You need double quotes for multiple characters. But there's a way to fix this. I could certainly just kind of cheat and be like, OK, I fixed my program. So now I can do make no switch. Now I can run no switch again. And now I can type in y, and it works. Unfortunately, now I can't type capital Y, so this is all kind of dumb. So what would be a better fix, do you think, to the program up here? Accept both of them somehow. So how would you do that? In Scratch, for instance, what would you do? What kind of puzzle piece would you drag in? Yeah. OK, we could use an or. Exactly. So there's an or puzzle piece, which you may or may not have used. And I would like to be able to just type the word or. But computers are generally a little cryptic, although some languages, Python, will literally introduce the word or again. In C, it's 2 vertical bars. And you just have to remember that. 2 vertical bars allows you to say if C equals capital Y. And down here, I can say if c equals capital N, now I can ask two questions at once. And so now if I zoom out and recompile this, make no switch, enter, and then go ahead and run next here, /no switch. And now I can do lowercase y, I can do capital Y, I can do lowercase n, I can do capital N, but I can't do like a question mark because there's no support for that. S doesn't work either. It wasn't one character, and the last was not y or n. There's another way I could have done this. How else could I have implemented this, especially if I didn't even know that these two vertical bars existed? What other puzzle piece or block of code could I use? Yeah, exactly. I could just have another else if. I could say if the character equals y, just as it was a moment ago. But I could also do this. Else if c equals capital Y, then go ahead and print out, quote unquote, yes as well. And then I could do the same for no. So how do you choose between these two options? Because this is just the first of many times where you're going to have to make a decision as to how to implement something. Someone like to argue in favor or against either of these? A little farther back. Yeah. Yeah, the first one used fewer lines of code, and frankly, that's a good thing, because the fewer lines of code, frankly, the less likely you are to have mistakes, perhaps, in your program, because you've written less code, fewer places to make mistakes. And there's another argument, I think, in favor of the first one, not just fewer lines of code, but what else? Exactly. The second one is also redundant insofar as I'm literally saying printf yes twice. And that just kind of seems unnecessary, right? We saw examples in Scratch where why do things multiple times if you have a loop? Well, same here with conditions. Why do things multiple times if you can combine them into one? Because plus, if you decide later on that you want to change the output to yes, exclamation point, you know, I could have updated it in half as many places if there were only one block instead of two. Now, you might disagree, and a reasonable person could make the case that, no, this is cleaner because it's just super explicit now what I'm checking for. And this is what's going to boil down in a class like this to something called design. There's going to be correctness, which is your code working as prescribed. But is it well designed? Like, would a reasonable person kind of vote in your favor that, yes, you did a good job implementing this, the equivalent of someone evaluating an essay? Like, yes, you expressed your thoughts, but they were all over the place. And you also have a third axis of evaluation, style. You'll notice that all of my code to date has been very nicely indented, and I have comments in the files that I wrote in advance. That's a matter of good style, which means you have sort of pretty looking code that's just easier to read than if you just wrote everything out onto one line. But more on those in just a bit. So let me go ahead and open up one alternative and not do this one from scratch. Let me go ahead and open up a file called switch.c just to introduce one other idea or one other feature. Whoops. OK. Accidental, but good takeaway. What did I just do, and why is this looking the way it is? I misclicked. Yeah, I opened the compiled file, the program, not the source code. So what I'm looking at is machine code. And because my browser doesn't know it's machine code zeros and ones, it's kind of misinterpreting the zeros and ones as though they are ASCII characters. Recall that ASCII was like capital A is 65, capital B is 66. The IDE is trying to interpret the zeros and ones in my program's machine code as though it's characters, but it's not actually English or English-like syntax. It's just random zeros and ones in a sense. And so that's why we're seeing the crazy characters and colors, because it's being misinterpreted as colors or characters that I didn't myself type. So no worries. Ignore the problem and close it. And then open up instead switch.c. So this is not a feature that Scratch had, but it's just to demonstrate that even in C, there's even more ways of implementing the same idea. Let me scroll up ever so slightly, and you'll see that up toward the top of this file, I have main as before. I prompt the user for a char. But this time, I'm not using ifs and elses. Notice I'm using a new keyword that we didn't have in Scratch called switch. It takes between parentheses a variable that you want to look at and a variable or value on which you want to make decisions, on the basis of which you want to make decisions. So you have 4 cases, it seems here, which are kind of nice in that they kind of say what they are. What does this program do when run, even though we've never actually looked at the switch statement before? What does it seem to do? What's that? Yeah, different cases, different options. So if I type in a capital Y to this program when it's run, what's it going to do? It's going to print yes. If I type in a capital N, lowercase n, and so forth, it's actually the exact same program. It's just written with a different feature. So there's different ways of expressing yourself, just like if two people are writing the same position on like a court case paper. They might have the same opinions, but they're going to express themselves differently in English. So in C, can you write the same program, behaves exactly the same, but you're using a different approach, and you're using different constructs like switches. And so in this case, case capital Y, case lowercase y, just mean if either of these two cases apply, do the indented code beneath them, but then break. Break makes sure that you don't keep executing everything below it. Because if I didn't have the break, the program would keep executing lines of code below it. And actually, if I typed Y, it might incorrectly say yes, no, because I didn't break out. You get the breakages for free, in a sense, with if conditions, because you have those curly braces. The switch does not use curly braces on the inside. It uses the slightly different syntax. Which one is better? It kind of depends. Sometimes it just looks better. And maybe the switch is, in some sense, a reasonable person could say, a better version of the program we just wrote, because it's just so much more compact. It's just easier to digest visually. I typed fewer characters, but maybe someone else would disagree and say, I rarely use switches. I never remember how they work. So this is actually less readable to me. So again, it's sort of to each his or her own in cases like this when it comes to design. All right, so let's introduce one other idea, one other building block that we've seen before, but we haven't done ourselves. I'm going to go ahead and do the following. I'm going to create a program here called return.c so that I can kind of implement the idea that Sam acted out for us. I'm going to go ahead and include the CS50 library. Then I'm going to go ahead and include the standard library. And then I'm going to do this, int main void, as before. And then down here, I'm going to do int x gets getInt. And I'm just going to prompt the user with the x. And then I'm going to say printf %i \n. And now I want to square x. So x times itself will give me x squared. Now, that's straightforward. This is not a hard program to write, especially once you know multiplication. And this would seem to do exactly that. If you type in 2, give me 2 squared, like 4. And so forth. But squaring maybe is a function that I like to use a lot, right? It's kind of a mathematical operation. And yes, it's obviously trivial to implement it with x times x. But it would be nice to abstract that away and just literally say the word square. Well, if your programming language doesn't come with a function called square, no big deal. We can implement it ourselves. We can do it as follows. Down here, I'm going to do the following. Int square, open bracket, int n, and then here, return n times n. So what have I just done? You might not have done this in your own Scratch programs, but you might recall from Gleck's lecture, we did briefly have a cough example with a custom puzzle piece. It was a purple puzzle piece. Coughing was not a block that existed when MIT made Scratch, but we made it. Squaring might not exist in C, or the libraries that we're using, so we're going to make it. How do you do it? Well, now we can begin to address, in part, the question that came up earlier about int and void, though only partially today. This is the name of my function. It's my custom puzzle piece, if you will. It takes as input, per the parentheses, one value that I'm arbitrarily calling n. I could call it m or o or p or anything I want, but n stands for number, so I went with n, as a computer scientist tends to. And all it does is execute one line of code, n times n, but then it returns the value. And this special keyword highlighted here is just like when Sam handed me back a slip of paper. He literally returned to me a value, a slip of paper. Here, I'm literally returning n times n. And that implies that what type of data is this custom function returning to whoever uses it? It's an integer because n is an integer. And it stands to reason that n times n is an integer. And so that is why I have also specified int here. It turns out that functions, to be clear, can take input and they can return output. If they take input, it's in between the parentheses, just like I've highlighted on line 10 here. And it's one input in this case, a variable called n of type int. But this function also, just like Sam's implementation of getString, returns a value. Not a string, but an integer. So I have to tell the computer, hey, this custom function I just wrote is going to return to whoever uses it an integer. And it's this line of code, line 12, that actually implements the functionality from which you get the value you care about. So now I don't need to do this anymore and reinvent the wheel. I can now use square as a keyword in all of my programs. But how do I call it? Thus far, anytime I've called functions, I've done like this, like int squared value I could do, and then I could do square of x semicolon. Now, I'm just kind of doing this intuitively, right? I don't know if this is best, but it does follow a pattern. On the left-hand side, I've declared a variable called squared value, though that's a little verbose. We could probably do better. But squared value, and it's of type integer. On the right-hand side, I'm calling square by just calling its name, open parenthesis, and the value I'm passing in as input, just like I handed Sam a slip of paper with input on it. And then I'm returning from the right to the left that value and using the assignment operator, the single equal sign. So how can I improve line 8 to finish that thought? Instead of typing x times x, what can I simply type here? Squared value, which is, again, a little dumb in that now I've typed more characters and really achieved the exact same thing. But I don't need this intermediate value. And here's an opportunity for better design. If I'm only declaring a variable on line 7, and then immediately using it in line 8, kind of doesn't need to exist, because you can nest blocks of code as follows. I can just take square of x, which I know returns the square of x. I can delete line 7 altogether, and I can more elegantly just do this, much like you can nest puzzle pieces. And this would be better design, arguably, because it's fewer lines of code. It just says what it does, and you don't have some random temporary variable just there to go from one line to the next. Maybe it's less readable, again, to each his or her own, but now I've at least done this.